Hello, we are Rabid Elephant, and this is a tutorial video for our new product, Knobs. Knobs is a flexible precision voltage processing utility with playability in mind. Knobs can be summarized as two voltage processing channels normal to a linear CV crossfader. Let's go over the two channels first. Knobs has two processing channels, channel A and channel B. Each channel contains, in this order, an input, a gain control with range switch, an aux output, an offset control, a slur control, and an output. Inputs A and B are normal to the internal 5-volt reference voltage when nothing is plugged in. The output of each channel is monitored by an RGB indicator which displays positive voltages in red, negative voltages in blue, and zero levels in green. The brightness of the LED displays the amplitude of the signal. The gain control range is settable with the range switch. In the center, it is unipolar positive for a gain of 0 to positive 1. In the upper position, it is unipolar negative for a gain of 0 to negative 1. And in the bottom position, it is bipolar for a gain of negative 1 to 1. The gain control is a configurable attenuverter and can be broken off from the rest of the channel by plugging something into the aux output. Here we'll be using this attenuator to control the level of an audio signal. The offset control is used to add a DC bias to the signal. Here we'll use the offset control to transpose the pitch of a sequence. The slur control is used to limit the rate of change of a signal. In this patch, it would adjust the portamento amount of the pitch CV. Channel A contains the active switch. The active switch is useful for manual event triggering or to quickly monitor or bypass processing effects. The switch has three modes: 0, bypass, and active. It's important to note that this switch is placed directly before the slur control of channel A, so any slur setting will still be applied regardless of the active switch mode. We'll send the output of channel A to the filter's cutoff frequency. We'll adjust channel A's settings with the active switch in the active mode. We'll then apply some slur. It's important to remember that since we don't have anything plugged into the input, we have 5 volts present at the input of the channel, so when we select bypass, we're actually sending 5 volts directly into the input of the slur circuit. We can activate the active switch and apply the previous settings, or we can zero using the active switch, applying 0 volts directly into the slur circuit. The last section of knobs is the linear crossfader. In this example, we'll be using the crossfader to set 2 fold amounts, which we will be selecting with the crossfader. We will set each side to the desired fold setting. That gap in the modulation, if you could hear it, is precisely why voltage processing utilities are so valuable. You can dial in exactly where you find the modulation the most juicy. If we plug a signal into the X-Fade CV input, we can control the position of the fader under voltage. Here we use the Vulcan modulator as our LFO. Even though the crossfader is being controlled externally, you can still bypass it manually by moving the fader fully to the left or fully to the right. So far we've been using static DC levels as set by channels A and B, but you can plug in additional time-varying modulation sources into each channel and adjust them accordingly. The fader can be positioned exactly in the center by moving it until the green LED illuminates. This allows use of a non-detented fader for smooth operation. Thanks for watching, and be sure to visit our website for more information or to contact us at www.rabidelephant.com.